And so this is going to be our agenda for tonight. We'll get started in the panel, but right before we get started, wanted to introduce Shahar. Very special thanks to Sift for putting on this event for us.
Thank you, Alice. You guys all hear me? So I have to say we're super excited that you all came in. This is the first event we're hosting here in the Seattle office. Sift has been in Seattle for about 2 years. Seattle is a big part of Sift legacy. Our founders came from Seattle. We have a lot of executives from Seattle, so no wonder once the company started growing really fast, they came back here to tap into this great talent that we have here. We work across the street. Last January, this January, we moved here, and this is the first event that we're hosting. We already collaborated with AWIP in the past back in San Francisco, and it's been a great success. So as soon as we heard that AWIP is building a presence in Seattle, we wanted to be part of it. So really excited he came here. One word about Sift. So some of you already asked me, what is Sift about? Sift is basically the market leader in digital trust and safety. This means that we let our customers protect themselves from all sorts of fraud and abuse without having to worry about this. You'll get some more insight into it when we talk about our experience and how we build AI products here during the panel. One thing I wanted to call out, actually two things. One, big thank you to all the folks at Sift and AWIP who helped organize. This is obviously Alice, but also Kavita and all the panelists. Folks on the Sift side, Rachel, our recruiter here. By the way, we're hiring product engineering positions here in Seattle, so reach out to Rachel, blue hair, if you're interested. We also have Mac and Gina and Delaney who all helped set up here at the event. So thank you guys very much. Hope you enjoy it, and looking forward to start.
Great, thank you so much. And with that, I'm going to be introducing your moderator, Kavita.
Hello everyone, thank you for coming down here despite it being a sunny day outside. So I just can imagine how committed you are for this. So I'm really happy to see you all here, and woo for you guys. I think one round of applause for yourself, right? Thank you. So I'm really excited to moderate this event. So AI is one of the space that it's like a new shiny thing, but they're like, okay, how should I approach it? How should I go about it? How should I think? And do I have enough skills? Should I need to be very technical? So many such questions. And today we are gonna unlock that questions and get the answers from our super amazing speakers here. So before that, let me introduce myself. I'm Kavita Gowda and work at Microsoft Azure, and I build products to put your AI workloads. So like 70% of AI workloads are going to go on containers, and I build a product portfolio for Microsoft Azure for such workloads. And before that, let's start introducing our panel. So you already met Shahar Ronan from Swift, and thanks Shahar for helping us to host this event, and Swift has graciously provided the space and the food, and thank you, it's amazing food. So why don't you come over and then take your seat. I would love to introduce next Palak. Palak is from UiPath. She's VP of Product, and she's innovating and applying AI in workflow automation. It's a B2B, and it would be nice to get her insights and her experience in running AI in a business-to-business product. Welcome, Palak. Next, let's welcome Kasir. Kasir is going to be coming from Amazon. He's a senior product manager for Alexa, and we are going to give him all the tough questions, actually. So because we have all interacted with Alexa, and he's trying to push the boundary into and make Alexa for our cars, and make our lives much more better. And we are going to ask him the tough questions around it and get more insight into Alexa's brain.
Thank you.
Welcome, Kasir. Awesome, that's great. This is our panel, and let's begin. So we are going to have, as I said, I've compiled a beautiful list of questions here for our panel, and then after that we'll give you and the panel questions will run about 45 minutes, and then you'll have the stage to ask all the questions to our amazing panel here. Amazing. So let's start with you, Shahar. So Shahar, tell me about your product. You have already introduced your product. but we'd love to know how you applied AI and how you initiate that idea into a security product.
So I talked about Sift in general. I want to talk a bit more about my product. It's called Account Defense, and it does two things. We help our customers block fake accounts from being created on our platform. We also help our customers prevent account takeovers. This is when legitimate accounts like my account, Balak's account, anyone else's account gets hacked, and somebody uses them to commit all sorts of fraud and exploitation. So the way that we do it is we currently protect over 34,000 sites and apps, and we collect data from all of these customers, feed them into our models, and in real time we provide a risk assessment for any activity that happens on the platform. So this is how we think about digital trust and safety, meaning that we are able to provide our customers some real-time risk score. They could take some action based on it, automate the action on this. This basically frees them from the need to worry about dealing with fraud, doing some manual reviews, or trying to figure out how to stop the bleeding. Because once we are in control, once our customers are able to use our data, they're able to just leverage this, automate these processes, reduce the cost of reviews, and then focus on growing their product. And a bit more about AI in this context, I mentioned that we're training all sorts of models. So these models are your typical machine learning models, obviously the typical state-of-the-art machine learning models, but they were built not just in a vacuum, they're built in response to a specific domain. So we need to understand our customers' problems, we need to understand what provides them value, how you show them this value. And this is where the AI part of the answer comes in. So I'm teasing it kind of now, but I'll share more information through Kavita's question later on.
So I work at UiPath, as Kavita mentioned. We build robotic process automation platform. What robotic process automation is excuse me, software robots that automate business processes and perform actions on behalf of users. So if you think about repetitive processes that require to read information from one screen, enter it into a different application, and then move the data around different systems and so on, RPA can do that for you. Now where AI comes into the picture is RPA has its limits. So the way we discover how to enhance and where to involve AI is based on two things. One is technology limitations, and second is customer requirements or needs. When you think about RPA, we're automating business processes, right? Today, customers have to know which process to automate and how to automate it. What we're trying to do is bring AI in to mine for processes and make it such that the tools can run, understand process, and automate it on behalf of the user, so nobody has to go look for this data. Second place that we leverage AI is in enhancing our technology. So at UiPath, computer vision is one of our strongest technologies. It's a big differentiator for us. And what that means is it's reading screens and backgrounds and things like that to extract fields from it. So text boxes, labels, buttons, and so on. This works great when you're on a web page or in a desktop application, but if you're thinking about a virtualized machine or an image that you need to extract from, you again start to need AI. And so that's where we innovate more and apply AI to this problem and help increase the accuracy of our computer vision models. In addition to that, we're evolving RPA effectively to become an AI platform in a way that everybody, to make AI sort of accessible to everyone.
Awesome, thank you.
So hi everyone, my name is Kasir. I'll actually ask you a couple of questions and then you know what I do. So I'll first just tell you a little bit about, I hope there's no Alexas here because I normally keep saying Alexa and usually there's a speaker that pops up. So okay, I don't hear Alexa, so that's good for a start. So I'm focused on Alexa, with Alexa in the car. And I'm going to give you some use cases and then tell you a little bit about how AI comes into the picture. How many of us have gone to a gas station late in the evening and felt a little uncomfortable? I don't know if this gas station's safe or not. And you still have to go out of your car, swipe your card to get gas. I'm assuming some of us, right? Great, good. Okay. What if Alexa could proactively tell you, hey, this gas station's safe, and as soon as you drive up, she could just tell you, hey, which pump number should I enable? And if you say pump 4, because you're logged into Alexa, you're using, you already have your Amazon credit card on file, she could remotely enable the pump. Wouldn't that be wonderful? That's maybe a little bit.
Yeah.
Or what if, how many of us, I know I'm one of those that always go late to meetings. How many of us have driven around trying to find parking? I don't know where there's a parking spot. What if Alexa could proactively tell you, hey, I see this traffic, if it's a new destination, so that's the AI element. She's getting data sources like traffic information, that it's a new destination, that it's downtown, and she's proactively telling you, hey Kasir, it looks like there's a lot of traffic where you're going. Would you like me to find and book parking for you ahead of time? So I think you get a good sense of customer use cases, and you get a good sense of the AI involved here. And I'll talk a little bit about the AI. The AI involved in the gas station example is, I ought to know that you're going home and not necessarily work. I don't want to bother you and say, hey, do you want to fill up gas on your way to work? So, Alexa or the system has to be smart enough to know that. Also, I don't want to push you to a gas station that's way more expensive than what you normally fill. You might fill gas at your home or workplace. Also, fuel level needs to be a certain limit. I don't want to tell you, how about let's fill gas if your gas levels are full. So, variety of factors that, where AI comes in and predicts that, this is a good time for me to tell Kasir to fill up gas, or this is a good destination for me to help Kasir find parking. I don't want to get bothered if I'm going to work every day and parking. I know where I need to park. So hope this gives you a good sense of it.
Yeah, thank you. Awesome. So it looks like you guys all identified where you need to put AI, right? So that's great, right? We all can come up with great ideas, and making an idea into a business is tricky. So how did you define a customer success metric or a business metric to say, this is going to be the success, this is what I'm going to measure to the success of my AI solution? Shahar, you first.
So this is working? Yeah, I think so. Okay. So I think that you probably notice that there's a certain recurring theme, like in all of our answers, about what AI is. Like, we're all come from different domains, we have different backgrounds, we're applying AI to different areas. But one thread that came through was AI is about automation. So you want to automate things that would be relatively simple for a human to do, but it's going to be very difficult for many humans to do this very fast. You'll need a lot of humans, you'll need to provide them some training, it will end up being very expensive. So AI is all about automating the process. In my case, when we talk about account defense or protecting customers for different types of fraud, there's already a manual solution for fraud. I mean, you can go and review every individual case that you have on your platform. But if you were to speak honestly, how many of you would be willing to wait, say, for 10 minutes until somebody reviewed your login request to a site? Or how many of you would want to, 2 days after you ordered something from Amazon, not endorsing Amazon, but from any online site, it's a pretty decent site, I would say. I use it a lot. No checks involved here.
Thank you.
But how many of you would be willing to, 2 days after you ordered something from Amazon, get an email saying, hey, you know what, this actually did not clear, so we're canceling the transaction. So being able to automate these things, instead of having lots of humans who need to constantly review these cases, make some of these decisions on the spot through some algorithm, is what AI is all about. And in our case, this is about making sure that you can log in instantly, so our customers, who are mostly consumer-facing sites, would be able to look at all the signals that we're sending them, get a real-time, very concise risk assessment, and be able to automate some friction based on this score. So I kind of touched on a couple of things here. Talked about automation, and I also talked about the need to have an accurate risk assessment. So in my case, when it comes to fraud, when it comes to different abuses or different security breaches, there are 2 metrics that we track. There are many metrics that we track actually, but I'll focus on 2 to simplify. So one thing is how accurate the solution we provide is. And this requires us to go and have some true set. True set could be labeled cases of manual reviews that were done in the past that mark fraudulent behavior on the site or hack logins or whatnot. And what we're doing is whenever we introduce new features to a model, we do some what we call experimentation, and we see how well these new features help us catch these types of fraud, these types of bad things that happened in the past. So this is one thing. There are different ways to measure accuracy. There are like the classic machine learning ways, area under the curve, precision and recall, but there are also metrics that are more meaningful to customers. In our case, when you're talking about fraud, like one metric that everybody understands is how much fraud can I catch if I introduce some nuisance to that % of users or that % of logins? This is something that helps fraud teams really think of what is the trade-off they're willing to make. But the other side of this is the automation part. All of this is great. We can have great accuracy, it would be amazing, but it's not worth a thing unless our solution is actually being used, unless it's actually being applied automatically. So one metric that we track is how many customers are able to automate on our solution. And when we see that this number is not as high as we hope, we can start asking ourselves, is there something that we can do to make it easier for them? Is it something that we can do to make it faster? Do they not see enough value? Then we can go there and start the investigations and then make it easier for them to automate, make sure they automate, and see how the metrics improve as a result.
So piling on to what Shahar just said, error reduction is actually quite important, right? And one of the things that AI enables us to do is reduce errors. The way we measure that from an RPA standpoint is when you have business processes that are automated, how often do they fail? And as the models get better, we expect the business processes to succeed more and more often. So that's one thing, one big metric that we measure internally for the models that we build for our system. Now, being a platform, we also build tools and models for our customers to use. So one that I mentioned before was around process mining and process understanding. The biggest measure of success for that particular tool is whether people are automating more processes, whether we are able to sell more robots, and whether those robots are being deployed or not. And it's a very simple black and white solution to some degree because you can see the direct impact of these processes on the business itself. And you can see the amount of time taken to run certain processes decreases significantly. And lastly, our goal is to measure user productivity. At the end of the day, everything that we do is to help make our lives better, every single person's lives better, right? So how do we measure user productivity? And in cases like contact centers, it's very easy to do based on how much time are people spending on certain types of calls? Are they reducing enough? Are we responding to customer requests within the first call, or do we need multiple calls to resolve their issues? How quickly are we resolving customer issues? All of these metrics are measurable. And the impact of the AI that we've built from our platform is directly correlated to success metrics in every single industry. And that's kind of how we measure success at UiPath.
I'll actually take a different trajectory. I'll talk about, so when you're building a product, you can, use AI one of two ways. If you have an existing product, you can use AI to find customer behavior. You can use AI to increase usage. You can use AI to find segments that you don't cater to. So that's one way where you're using artificial intelligence. You could use something as basic as regression to just find out what are my customers doing. And I'll give you a good example. Imagine you're a product owner of a product that has millions of customers. In that scenario, it's really hard for you to find out what are those customers that I might lose, because of fraudulent accounts, bad experiences, because I'm taking too long to cater to these customers. So for those, you might have certain business metrics. What is the probability that X customer is going to churn out of those million? And if I can find the top 100, top 500 customers that are at risk of leaving, those are the ones I can target. So that's one way of going at it and coming up with metrics. The other way is AI could be inherent into what you do. A good example is voice. With a voice-based solution, it could be I'm sitting at home and I say, Alexa, turn off my living room light. In an ideal world, Alexa should be smart enough to know that if I'm sitting in my living room and I say turn off the light, she should be smart enough to know that, he's in the living room and he means the living room light. So, so this is another way where you incorporate AI within the product. And in that scenario, it could be other metrics on, did I actually do the right thing on what the customer asked me? And there are examples where you might just ask your voice assistant to stop, or where she doesn't necessarily understand what you're saying. So I split it up into two buckets. One, how do I make my product better in terms of just knowing my customers and usage? And two, can I just put AI within my product and can I have measurements there that help me derive better quality or even more revenue?
So it looks like we have got multiple metrics to make our customers' life better, right? So to do innovative stuff even before they understand that this AI can make their life better and we track it. But again, AI, we have all touched AI today, we all use it, right? And we don't even know many times we have done it. But one big question and problem that always stays for a product manager with AI is the uncertainty, right? The accuracy of the algorithm, precision, and then the bias. So how, and that's related to sometimes your metrics, and how do you work around it and still give value to your customers?
So there are a few reasons of why things could go wrong. And I mean, I talked about some metrics. I think accuracy is one good way to look at this. You could see that your accuracy is dipping, or you could see that accuracy for one customer is not what you would expect at this point compared to some baseline. And you can go and investigate it. And the problem is that, well, there are a couple of problems with AI. One of the things that a lot of the models that you implement might be black boxes. So it's not clear what is actually happening, especially when you're looking at super complex models, like big neural nets, for example, or things like that. Those are not simple to debug. And then you start going back and try to figure out like what went wrong. And almost all the time, it's some problem with the data. So first step of AI, you need to have a lot of data. All these models that we're talking about, the reason that Sift can do such a great job preventing fraud, the reason that UiPath can automate these processes, the reason Alexa can do so well taking your car to a safe gas station, is because there are a lot of instances that they can train on. The problem is that these instances are inaccurate. If there's something wrong with the labeling, if there's something wrong with the structure, nothing will make sense. The results will not be effective. So first step of AI is to have a lot of data, but also have a way of ensuring that the data is accurate and correct. So you need to be very strict on defining what is good data. You need to have some means of making sure that the data is right. And more than anything else, you need to make sure that your customers have a way of sending you, easy way of sending you data that will be accurate. The other step here, so this is how you remove one level of uncertainty, because whenever there's a problem, you can always go back in the data and look at it. The other step is to have a good way of debugging your model. So once you know that your data is fine, you want to make sure that your model is tuned the right way. And there are a lot of things that can go wrong here, especially with the more complex models like neural nets. So having some visibility into what's going on, having a platform, an experimentation platform that lets you repeatedly test different options and see what gives you a lift and what does not give you a lift or what makes it worse is very important. So the second step of AI is to set up the right platform that allow you to test all these options. So remember, you're going to have a ton of data, and there are going to be a lot of things that you can do with the data, so you want to be able to test all these options, but also understand what happens when you test each one of these options, so you can see where you need to fix it or not. This is the second important thing for AI. I'm sure there are a lot of other steps, but I'd like to let the other panelists also comment on this.
Shahar covered some very good points. I'll just add one more to it. One of the things that's really important is, especially for a platform, is to have some customer validation of the data. And so let's say our model is accurate 80% of the time, or even 99% of the time. That 1% where it's not accurate, we need some way to respond and let the customer interact and fix the problem, so to speak. And so some of the things that we've done to reduce this error is add a validation station where humans can go validate that the data or the model has processed it correctly, or if it's inaccurate, actually train the system to do a better job next time. And that's, as someone who works on the sidelines of AI to some degree, I find that to be a great place where VPMs end up adding value, is designing experiences that can help mitigate some of the possible errors of AI models.
I'll actually, great points, and I don't mean to pile on, but love your example about data. I think with any AI model that you do, whether it's supervised, unsupervised, you want to look at input data. And I'll give you a quick example, right? Let's assume, you're a company and you're trying to hire people, and you get data, say, you already have X type of people in your company. That type of people may itself be biased. So if you use that as an indicator to hire people, you're not going to get a good, clean data set. So just simple examples, right? Having good, clean, randomized data is very, very important for a model. And with supervised learning, you also want to look at labels. Maybe having weights for by labels I mean features. So if let's take an example, a model that is trying to pick winners in a race. You might have age as a factor. Is that a good example? I don't know. Is that a good feature or a label? I don't know. So it's just having the right type of data and having the right weights attached to that model. That's very, very important because I think you've heard this, right? Garbage in, garbage out. If you have good data, you're going to get good responses. You're gonna, your accuracy is going to be much higher.
So I think I got data is the king at last. Good. So I think when 10 years ago when Facebook started and everybody's like, data is important, oh, this is going to be great, Facebook stocks are going to be great. Like, why? Why? What is about the data? I never understood, but now I know what the power of data and everything. So maybe I'm matured enough to understand it. That coming to that question then, right? Especially you two are in B2B business to business scenario. Getting data is not easy, right? And for each customer, getting that is easy. Like, in terms of Alexa, like there's a lot of interaction that happens that you can continuously fine-tune your models and remove the bias. But I want to know, maybe starting with Polak, how would you collect data for each customer, or do you randomize it across, or you collect data per customer to run your models?
So we do a couple of different things. One is, honestly, as you said, it's very hard to get data, and especially business data, where it's very sensitive and customers aren't easily willing to share it. So we'll get it wherever we can get it, in the sense that there are some customers, some enterprise customers, who are really open to working with you because they want to, see efficiency gains in all of their environments. They want to see productivity gains everywhere, and they have entire AI centers of excellence established, and teams of people whose focus is to apply AI to their workforce. And the way we do it is we work with these customers who are willing to share that data, and sometimes it's in a controlled environment where we have to actually go into their machines, even their offices sometimes, to go access the data, run the models locally, and then bring the learnings back. We also, there's a ton of legalities involved, a lot of security, making sure the data access is restricted to the right group of people. A lot of our AI PMs actually spend the majority of their time dealing with security and legal issues more than actually getting the data in-house or working on the data. It's quite a big challenge. Luckily, there are enough large customers out there who are interested in evolving this field, and we end up working with some really cool ones. To the second point of do we work on special ones or not, in some scenarios we do target special customers, like for process mining, for example. Contact centers, the agents at contact centers have the least amount of variance in what they do on a day-to-day basis. And so we target those customers for monitoring because it just gives us a more cleaner data set than if we were to go to a receptionist, for instance. And so we do some of that, but frankly, we get data wherever we can.
Yeah, that's a good point actually. That means like we do not have to stop innovating in a B2B business because we'll have problems with getting data, right? So I think the next question is to you, Shahar, is that you're in a security defense product and you collect data. Not only the data has to be collected, but also it has to meet a lot of compliance to make sure that you are also securely using the data to secure us. So how do you go about that?
Yeah, so just to give you a context about what kind of data we collect. So our customers are consumer facing, and they have users like you and me, and they're doing all sorts of activities on their site, and they're sending us the data. And now you're thinking, okay, this could be a problem, right? Like customers are just going to blindly send us their data. So one thing is we want to make it easy for them to send the data. So we have a solution that scales pretty well in the sense that there's some JavaScript tags, there's some REST API integration for customers with apps there's a native SDK that they can work with. All of this to simplify data and make sure there's some redundancy in the way data is sent, so we're not skipping a beat. If a fraudster tries to disable JavaScript, for example, we will still get some data about this login, about this information. We want to make sure that we're covered. But the other part is also, once we get this data, and once we structure it, and once we have APIs that are public-facing so customers can understand, and we have integration planning sessions with our major customers so they can understand what to send. But the other part is also educate them, what does the data mean? Sometimes they don't understand what's so important about the data, or why it's so important to keep it in a certain way. And sometimes we're getting to integration discussions with customers and they say, okay, we have these names and emails and social security numbers, we'll just send them to you. It's like, hey, whoa, we're not gonna take your social security numbers, here's why. So we see that there's a lot of education that we need to do with some customers. I mean, granted, we have some customers who are super aware of this. They would not even send us usernames, they would just hash everything, and obviously it limits the ability of us to do things, but we still can provide value, and it's a trade-off that they're willingly taking. They're making an informed decision to take it. And we want every customer to be in a position where they can take an informed decision of, here's the risk associated with these things. Some things we'll never take, like social security numbers, but some other things, email addresses, yeah, you can send it. Here's how we comply. We comply with GDPR, which means that if a user wants to be forgotten, they could contact the customer, they could contact us directly. We will make sure that we no longer collect this and we erase any existing records. We comply with SOC 2, which is about how you store data. Any companies that stores customer data needs to comply with this. So we can explain customers what kind of compliance we have and how we're walking about this, how we're working with this, and then educate them what makes sense to send or not. And when people ask me, like, how do I spend most of my day, I would jokingly say, well, I talk to recruiting half of the time, and then I talk to compliance the other half. Everything else just builds itself.
So it's complicated, right? The data compliance, and there's so many compliances that you have to keep in mind. So it's gonna get complicated more for you, Kasir, as well, right? With Alexa. So the one thing I always hear is Alexa is always listening to you. Okay, shh, be quiet. So and turn it off. So tell me, if you're in a personal device space, right, with AI, how should a PM think about data compliance, and how much is the data, and how do you make sure that you strip off the personal information and use the data to your advantage?
So let me, I'll give you an answer in terms of how you want to do it if you're a PM, and this is my personal framework that I've created, so it's copyright. I'm joking. So what I try to follow is, basically what I call, whenever you use data, it has to be fair, it has to be flexible, and it has to be functional. And I'll explain each of these. What I mean by fair is, don't collect data if you're not going to get some value out of it for the customer. If you don't need the SSN, don't collect it. Why? You have liability issues. There's breach, there's a lot of other things, and you don't want to be creepy. So there's different levels. So I call that being fair. Only collect what you need and explain to your customers why you need it. And the second one, I'd say flexible. No one customer is the same. There are certain customers that will share everything, and then there are certain customers that won't share anything. And there's a spectrum. The worst thing what you can do as a product manager is say, I have two extremes. It's all or nothing. Guess what? You're not going to get the data, and then they give examples of how hard it is to collect data. You'll end up getting biased data again, which is people that are willing to share everything, and you don't get any data from people that might be willing to share certain things. So be flexible for your customer. Show them, based on the data that you're sharing, here are the different spectrums of benefits that we can give. And then the third one is functional. If you're sharing something, tell them why. Tell them that I know you're sharing a telephone number. Guess what? When you go to a gas station, you get discounts out the back. You don't have to enter your telephone number to get 5 cents off gas. If you give it to us once, we'll automatically input it for you. All you have to do is enable the gas pump and you get your discount. So that's the value add piece. And I'd say, you could pretty much use this framework for any product that you're building around data sharing, whether it's B2B or B2C. Collection, I think, is a whole different animal.
Yeah, makes sense. So I think what I've heard from all three of you is definitely take consent from your customers, right? So so in B2B, I think it happens because there's a lot of it personal devices. In other cases, still have a way where they can consent how much data that you collect, and then have it on your side. Makes sense. So I think now let's get on to implementation, right? So now you have come up with a super idea, you define the customer metrics, business metrics, and convince the business. Now you need to talk to engineering. So Shahar, so how did you go and how do you go interact with engineering, and then when you give an idea, how long does it take to productionize your models?
Yeah, I think I want to demystify interact with engineering here. So, especially since some of the engineers I work with are listening. I think that the idea where a product manager would come up with an idea and an engineer would implement this does not make sense to me. It's not a waterfall process. As a product manager, my goal is to create the infrastructure, create a process that enables the people that I manage or cross-functionally manage be most effective. And this, when it comes to engineering, it's creating the process where they understand why we're doing the things we're doing, they understand the purpose of the work that we do, and they understand how the work they do impact the customer. And this inspires them to discuss together, like, what are the best ways to measure this impact, how do we quantify these qualitative notions and put this into some numbers so we can actually repeatedly experiment and measure this. Once you have this covered, then implementation, design implementation become a team effort. So it's not just me coming up with ideas, engineering, implementing, it's I give them the vision and they come up with their ideas, which are often better than mine because they spend more time working on this and they have a better understanding sometimes of the constraint of the system. Then we can work together to prioritize those. So one of the questions that you get asked is like, how long would it take you to create a certain model? And there's no like one answer. A model is a very high level work. You can have very simple models that are basically a set of 3 rules. For example, to prevent account takeover, you could say that all logins that are coming from IP that we've seen more than 3 times across different accounts in the system, we will just block. And every time we see multiple logins happening to the same account within less than 10 seconds, we will just block it. Some basic rate limiting. And honestly, you can go and implement this if you know your system well enough in a couple of hours. It will probably be very, very effective. If you never had anything before, this is going to substantially reduce the number of fraud and account takeovers that you see. But then, as always with machine learning and with modeling, just getting to the next level becomes harder and harder. I think that's like anything in life, in a sense. So then the next step is, I already have this, how can I implement a smarter model? Maybe some regression model, maybe some decision forest or something like that. And this could take a bit longer. You need to collect more data, you need to do experimentation on the data. It could take maybe even 2 weeks. And then you could also have models that would take months, just because getting the data, cleaning it up, doing experimentation, understanding how you can fix some of the things that you're not getting, realizing that you're not collecting some critical data, putting it aside, waiting a quarter until you collect the data because you change your API and now customers are adjusting to it, and now coming back to the model and revisiting it, yeah, it could be easily 6 months before you introduce a very complex model. So there are many ways of doing this, and as a good R&D team, what you need to have is not just one notion of here's how long it would take us to do something X, but also here's what we're hoping to achieve with this model X, here's how we're going to measure it once it happens, and here's how much time we think it's going to take us. And then ideally, there would be some gradual gating process where you'd be able to fail fast. So you try something offline, it's not working, you know there's no need to continue experimenting there. You need to either fix something pretty early on. If you try something, it works, then you can take it to the next step. Because each one of these steps is going to be costlier and costlier as you get closer to deploying to production. Once you deploy to production and it's actually starting to impact your customers' logins, it impacts like all the experience that their user has, this is pretty critical. So you want to make sure that you have everything verified and you have full confidence in your model before you do that. So long answer short, there's no single answer. You do need to have good metrics. You do need to have a good process around this. And then you do need to be able to fail safe and fail quick at any point of this process.
Okay, I'm gonna take fail fast and take it to production. So tell me a time, I think maybe Kasir or Shahar or anyone, share your experience when a scenario that was powered by AI was with customer went into production and it failed. It did not work as you imagined. And I guess it always happens. So how did you go about putting a remedy to it and how did you approach it?
Yeah, sure.
Okay, I'll go first. So last Tuesday, no, I'm just kidding. It does happen every once and then, obviously. So we integrated with a customer. It's actually a pretty big customer. It was a complex integration because these were 2 relatively new products at the time. So one's my product, Account Defense. The other one is our Content Integrity product. So they're integrating with these 2 products. They're still in trial. So there's a lot of revenue at stake. Content works well. Account Defense, not that well. And we're looking at everything, and we noticed that they did integration well. They're seeing some ATO attacks, but our model is not picking them up. And then as we investigate a little bit further, what we realized is that they did not integrate the right way. They sent us the wrong data. Instead of sending us the IP for the client, they send us the registration IP. So their domain that's registered the IP. Effectively, there are 5 IPs that we see all across our system. And again, we're talking a site with millions of users every day. So instead of seeing millions of IPs, we see 5. So our models are not going to be very effective in such a scenario. So what you need to do in this case is they need to fix it. You need to retrain the model, and then you can evaluate performance, and it did very well. But what we realized out of this is that we need a way to quickly understand that things are not working well. Not just assume that there's some safe path for integration, that if they send us this information, it's okay, but also have some sanity checks about the quality of the data they send. So now we have a process that's a combination of some automatic process and some manual scrutiny, but it's baked into our customer success plan. Basically, when a customer integrates, they go through this process, and only when they get we give the sign up. And again, this is limited to major customers. The typical ones, the smaller ones have simpler scenarios usually. Only then we we flip the switch, and we start actually measuring performance in production.
Cool. Let me give you an example of skills. Skills are programs in the Alexa world. I'm pretty sure many of you have used skills. They're available to turn on the lights, etc., so on and so forth. So one of the products that I lead is called Connected Car Skills, which is, you could tell your Alexa Echo device at home, hey, lock the door, or lock the car door for that matter. And one of the pieces that, we were looking at reviews, and a lot of reviews for certain car skills weren't so great. So started diving deep and saying, Alexa's pretty much doing what the customer's saying, and you would look at reviews and it would say, hey, Alexa didn't understand this, or it's not working. Come to find out that the way the car manufacturer had coded this skill, they had what is called sample utterances, which is what is used to train the Alexa model. Sample utterances are lock the car door, lock my car's door, lock the driver door, and for certain skills, customers were saying lock my truck door, and the software developer that had coded the skill didn't have a sample utterance that says truck door. Such a simple thing, and people were, it doesn't work. I told her to lock the door, and I'm like, oops. Truck's pretty much the same as car, but when a software developer, it's not the same when we speak about it, but when a software developer coded it, they just didn't have the right terms. So simple things like that can make a very big difference. And I'll also tell you a solution. So we looked at it one of 2 ways. One, can we allow software developers to create friendly names? So a good example is, if you're sitting in the car, I might say, Alexa, increase the fan speed. Someone might say, Alexa, increase the blower speed. And now another person might say, Alexa, increase airspeed. Same thing, but it's just making Alexa smarter at a level where she understands that these mean the same things. And I know one of my engineers here, so he actually works on that. So he's dozing off. Don't want to call you out, I'm joking. And the second part is also telling software developers that you could increase coverage by looking at your entire portfolio and talking about, can you just have utterances that are very much relative to your product portfolio. So just don't have car door, have truck door, have, for example, your Ford F-150 door, so on and so forth.
Cool. So looks like you're leading me to skills. So this is not about Alexa skill, now it's the PM skill, right? So the most common question that get asked is, what skills do I need to be a product manager in AI industry, right? So does that mean, should I go to MIT and get a data scientist or become a data scientist, or how much I need to start coding a model, how much deep I need to know, regression, tree, branch, all the kinds of models, right? So you guys tell me, what is that, and this is for each one of you, I want to gather your ideas around that. So what does the skill set we need to gather as a PM to be effective in doing AI solution for our products?
Okay. So, the AI team is built of many different roles. It's not just PM and engineers. Unlike traditional software, there's PM, there's data science, there's people who just analyze the data or correct the data and sift through it. They're not ML engineers or anything. They're just people who like working with data. And then there are engineers, right? Now, there is a role for every single person in this journey of bringing an AI product to life. So depending on interest, my recommendation is that the best way to learn the skills is, you can do courses on Coursera and learn about how to build models. But AI is more than models. There's data that you have to deal with. There's infrastructure. It turns out in order for models to scale, you actually need very high compute power and lots of infrastructure. And our engineering team spends as much time on infra as they do on building the models or getting the data and sifting through it. And so, depending on interest, there's application and just building experiences around AI, which is where I spend a lot of my time, where as a PM, what you need to be aware of is what are the latest trends, what kind of technology is available, where can your product gain value from integrating AI to going and doing that degree in data science and learning more about that aspect of it. The best thing to do though is start by working on a project that you can learn from experts on, because it varies so much from one company to another. The infrastructure varies, the types of data varies, even the models vary significantly. So just getting experience by working on a project, working with peers who are experts in this space, you'll learn a lot more than I think just learning on your own on Coursera and such.
I have a question. How many of you build or ship products? Okay, so you have all the skills you need to build and ship AI products. Because there's no magic around AI. I mean, if you're able to understand a customer's problem, if you're able to prioritize prioritize pains, come up with MVP solutions, and then make sure that these solutions get delivered, you'll be able to deliver great AI products. The thing that is different with AI is that for some reason there is some mysticism around AI. So people tend to think that there's a lot of things that they need to learn. In reality, even though I have 5 years of machine learning background, I don't think that this is what really made the difference here at Sift. I think that what made the difference here is to understand how to build a team, understand how to prioritize customer pains, be very passionate about this particular domain, fraud and security, which again, I had no background at. And then make sure that I can basically motivate a team and work with them and create some processes that help them ship AI products. So I think that my biggest tip to you is think what will make you be a better product manager and apply these skills to the next product you're going to work on. If you want to get into AI, find a problem that you're really passionate about. It could be anything. It could be fraud for me. It could be, conserving water. It could be environment. It could be improving ad monetization for big ad players. If you're passionate about this, more power to you. But just stick with this domain, ramp up on this domain. Yes, it's always useful to take a few courses or read a few books just to get an understanding of what are the possibilities of AI. This is not what's going to make the difference. What's going to make the difference is your ability to relate to a customer and work to finding a solution that actually matters.
Okay. So want to add on that, right? I saw two segments here. One was, people that already own products, and two were people that are, maybe trying to be product managers or trying to learn about AI. So love your insight on existing product managers. Find a problem that you have today. I'll give you a good example where you might have many customers, and you want to try to find out, hey, what are my chances of losing customers? Churn. Is there an easy way you can find that out? And of those customers, can you prioritize? This is a good basic regression problem. So I would say start with the problem first. Ideally, a problem that's not as, that could be rule-based, and you could potentially run an AI model or do something as simple as machine learning regression. That will also give you the push and the benefit. You'll get visibility within your company, within your team. And it's also a push because, if someone tells me to go learn or do a 6-week course on Coursera, I'll go sign up and then I'll never go back. But if there is a work issue and that that I think can save me time, save me potentially get me some visibility. I'm a bit more motivated to do things there. So I'd say start with that as a baseline and then look at what are your available options if you're existing product managers or if you're trying to enter. If you're trying to be a product manager, then a good way is maybe start with Udemy, Coursera, look at certain verticals that and read about what are some problems there and can I use certain machine learning models. Also, I want to take a step back. If you look at certain cloud computing solutions, there's AWS, Google Cloud Platform, all of these today already provide you existing APIs or tools where you simply push the data and they give you relevant examples, relevant confidence levels. For example, there are services on the AWS world. If you give it an image, it'll tell you, 80% probability it's a cat, 20% probability the cat has a hat, etc. So on and so forth. So you don't really even need to know the depth or become a data scientist to know what you're trying to solve. And there's a good example on, you could have an e-commerce site and you're trying to find, are the pictures relevant to the description? So you could simply find a way, call this API and say, someone's trying to sell a bag, 80% probability that this cloud-based API is telling me it is indeed a bag. So, I think you should just start with what is that problem that you're trying to solve? Is there relevant AI solutions out there that can help you?
Makes sense. So maybe I'll sum it up. So you need not know in depth of how you take the data and run the models, but I think the first thing that you need to know is what's the possibility with AI, right? What are its limitations, how I can apply it, what are the applications, and understanding the precision issues, and then the limitations and application. So that will start you with ideas, how to go about it. And maybe that you don't have to do AI for your product, you can just say, hey, we have this data, so maybe this customer is more, has more attributes to buy your product, or something of that sort. And what I've seen in the past is many of my friends have just suggested these particular features to their company and to their product, even being in the engineering side and others. And then people are like, oh yeah, can you give us a little bit more? And then they have done the simple data running regressions and things like that. And you have so many tools out there where you just provide the data and understand a little bit, it's going to give you outputs. So, and they've thrown it back to the business or the product team or somebody else, and they're like, oh wow, we could have done this. So that has also given them the stage to go back. And one of my friends, by doing this, she became a head of AI for a company. So this limitless, so this area is going to grow. So by saying that, I would love to open up for questions to our panelists here. There you go. So how would, you know what, let me give this to you.
Hi, thank you. It's so insightful to hear each one of your perspectives within your area, your product areas. My question for anybody on the panel is, from a product perspective and going to market, reaching your customers sooner, how do you deal with scale within the context of AI? You have to take along the features and the capabilities, as well as the infrastructure and the models with you. I'm keen to find out how you tackle scaling issues and problems.
Go ahead. I'll take a shot at it. So I think that one of the things that I find pretty cool about Sift is that it was built with scale in mind. And it doesn't mean that from the beginning we have like all the services that we needed or everything that we needed, but the idea was we want to serve different types of customers, and we need to build a platform that could easily scale by adding more nodes on the cloud service, and also by expanding the data structure. So like however we structure the data, it's expandable. So a cool example is we have some reserved fields and reserved events in our platform. So think of logins or transactions or things like that. And there are some attributes that would associate with a login. There's like the IP of the login, there's a user agent, all sorts of things that help you understand where it's coming from and what's the purpose of this. But we also allow our customers to send us custom fields. So this way, we can do some experimentation and we can track the data. And if we see that customers are having a certain need because they're sending us custom fields that they cannot be addressed with reserved fields, this is a good signal to us that we could just add this as a reserved field later on. This is a simple example, but it's like a way to on one hand, like recommend a certain best practice to your customers and enforce it by having some validation on a schema. But on the other hand, also allow them to give you some feedback, some indirect feedback that they need more than what you can give them. I'll stop here because I want others to reply too. You don't have
No, we are good to the audience. So, yes.
Okay. So I think I'll add on the same lines. So the question was around scale. It's very ambiguous. What do you mean by scale? So I'll explain at different levels. One, when someone talks about scale, I mean about different customer segments. So with that in mind, you would look at what are the data fields that are common across my different segments. Can I use those as a baseline to build my model? So for example, I might only run in North America and I want to eventually include Asia, but you might have common data fields like date of birth, age. With date of birth, you could have IP logins, etc. Fields that are generic, and then over time you can build models that are very much customized to those regions or those customer segments. The other part about scale is from a technology perspective. You could obviously do scale by having your own EC2 instances, which is basically your own virtual machines that scale over time, or you could use certain APIs in the cloud that automatically scale based on the amount of data you send and based on the amount of processing that you do. So it's just different scales. For early startups and early products, you could even start as small as running a model on your own laptop for that matter, or simply picking up a virtual machine or using a very simple API online. There's a lot of tutorials out there, and then as you go to production, you could take your pick, something that you completely build in-house with the help of your data scientists and your software engineers, or something that you just pick up readily available AI APIs on the cloud.
Next question.
Awesome. So yeah, this is Bill from Amazon. So I want to ask a question about the skills. So the parents have more focus more on the AI side. I want to ask maybe off the question as a AI like a scientist, how to be a manager? Let's say how to get the management skills.
Yeah, so let me repeat the question for maybe people on the line. So you're asking, how would you manage a AI team or AI product? Is that right?
I think you're trying to, and please correct me, I think what you're asking is, I am an AI scientist and I want to go the managerial route and become a manager. Is that accurate?
Okay.
Yeah.
Managing the engineering team?
Yes.
Okay.
Great. So I'd say, if you want to switch, it would be pretty much the same as, you would obviously, as someone, a PM who's trying to manage a team, or a software engineer who's trying to manage a team. So I'd ask you, if you're from the AI side and you're laser focused on AI, one way to start could be simply mentoring existing new data scientists in your team and focusing on your strength, which is building AI models and building machine learning models. So that could be one way where you show that you're able to effectively mentor people, you're able to grow them, ramp them up much faster, and that could allow you to become a manager within your team, and then you could eventually scale and talk about how you could go over and above, rather than a PM providing you input on a potential feature that you require, that might require machine learning. You could go over and above and say, hey, here are some big problems that I see in the business, or big opportunities, and here are some suggested AI models that I can deliver. That also gets you visibility within your team, and hopefully tracks you for a managerial position that spans not just AI scientists, machine data scientists, but also other team members.
I want to add one more thing to that. So management is about leadership, right? And you have opportunity to demonstrate leadership in every aspect of your job, proactively working with customers, making sure that you are seen as a technical leader on your team even. Without having people reporting to you, you can become a go-to person for whatever space you're working on, right? So mentoring is the other important thing, but it's always about demonstrating leadership, and the manager role will happen naturally. Just focus on how you can make sure that everything you do is leading to the greater company benefit.
Simpler answer is take your manager for a drink. Next question, please. No, you're good.
So I have a question kind of about the difference between just the rule-based functionality that you can introduce versus what is really considered AI. Because we talked about how, there's like basic levels where you just, create a bunch of rules and it's not necessarily intelligent in a way, but it's just, it's efficient. It makes it work faster. So what is kind of that differentiator? Like, what do you actually call AI? Is it machine learning? Is it when you were trying to evaluate based on those data sets and then make some decisions? Like, what is that? Like, can you clarify, please?
All right, yeah, I'm happy to take this one. So I would say let's take a step back and talk about like machine learning versus AI. Machine learning is a certain tool that you have. Machine learning is the ability to let a computer understand what needs to be done without explicitly telling it what needs to be done. AI is a way to solve a very specific, typically automate a very specific task. One way to think about this is if a human can make a decision in a second, AI could help a computer make a decision about this in a second. So one way to build an AI solution is to use machine learning. It's not the only thing that you would need. You would probably need a good user experience. You would probably need a killer UI. You would need an entire infrastructure to power the whole thing because it needs to be very specific to the domain that you're trying to solve. So one way to start a product that would eventually be an AI product is to actually have a rule-based system. If you have a really good rule-based system that is able to achieve high accuracy, even for a very limited scope, you could pitch it as an AI product, sell the future a little bit here, as long as it's actually helping automating processes and helping achieve what the goals are. AI is more about what is the impact that you're getting than how you actually implement this. Longer term, chances you will not be very competitive if you only have a rule-based system. So this is where you start introducing things that are more complicated. One of the flaws of a rule-based system is that it is typically, by design, it's looking at the past, not at the future. So you keep adding rules that help you deal with problems that you've seen in the past, and you need to have to maintain the system. You end up with having thousands of rules that are sometimes contradictory, are becoming very difficult to maintain, and then they're not really anticipating anything new. They have no capability of adapting. And this is where machine learning models comes in. Because once you can train on a certain data set, and it's a good data set, you have models that capture not just what is happening now, but are able to detect certain anomalies and certain things that you have not anticipated. And as long as you have the data coming in, and whatever approach you're taking, if it's supervised, unsupervised, as long as you have a good way of leveraging it, you'll be able to quickly adapt to new things that you see. And I would add that in the early days of Sift, one of our biggest differentiator was our machine learning models. Because the entire fraud prevention system was rule-based, and this was terrible to maintain. So Sift was able to land its first customers just because of having machine learning models that worked pretty well. Fast forward 4 years later, 5 years later, everyone aligned. Everybody says they have machine learning models. What really this machine learning does or how good it is, nobody can tell. But machine learning is no longer a differentiator. What is a differentiator is how you interact with the system, how well it does, how easy it is to start using it, and how quickly you can see some results. So yeah, definitely start with a rule-based system. It's actually a great way to build some intuition about a certain field and come up with a quick and dirty solution. But next step is, how do you scale it? How do you make sure that you're always up to speed on what's happening?
I'd love to give you an example. So I used to work for a healthcare company in the fraud prevention space a long time ago, and the experience was very typical. As you mentioned, there were not thousands, millions of rules to prevent healthcare fraud on claims. And I'll give you real rules. A good example is, it's very weird if a person's having a heart surgery every month. It's not normal. However, there are cases where a person does have heart surgery, every other month, and in that scenario, a healthcare company ought to be super fast in approving that surgery. Similarly, so all of this processing in the old world with that healthcare company used to mean someone would look at their healthcare claims. These were real doctors sitting in Southeast Asia. I would actually parse through a person's healthcare history and say, yeah, looks like, this is a good probability that this guy does need heart surgery. We're going to approve it. It's not fraud. That takes a long time to parse through the healthcare claims, look at health records, make sure that the doctor who's approving this is indeed a real doctor, make sure that the doctor is part of a certain hospital, because you could have people that just steal your healthcare identity, file healthcare claims, and create fake doctor profiles, and they're getting reimbursement checks. So step one was what they had were thousands and thousands and thousands of rules. Step two was, okay, can we now collect all the data that's associated with this patient? Can we have a separate database of approved doctors? And can we now build a model that gives us some confidence that says, yes, doctors approved, looks like probability of fraud is 20%. Oh, this guy had, his healthcare claim does show that he has heart issues, probability of fraud 5%. So you can see how the probability goes down. In a reverse manner, in machine learning, the probability might go up. The thinking here is, if probability is above a certain limit, you will then only send those healthcare claims still to that team out in Asia that's then going to parse and say, yes, definitely fraud. What happens is now you reduce the cost of detecting fraud. So in this healthcare example, previously this company was looking at healthcare fraud only when claims were above $1,000. The reason is it takes a lot of time, money, and manpower to do this. They then steadily dropped it to $250. And I'd love to tell you it was a reason why they started doing this, because fraudsters are very, very smart. It's a police game. You're trying to fix a hole and they'll find something else. And I'm pretty sure you see that all the time with account takeovers. We started seeing a pattern where, guess what? Because they found out that healthcare claims below $1,000 are not getting detected, we suddenly started a lot of influx on healthcare claims, which were $998, $999. So I think you can see how the model works and how it starts analyzing how we do work.
Awesome. So we'll take last question.
We actually have a question from Facebook Live. So the question is, what are the skills that one needs to look for when picking an AI engineer or data scientist for their product other than the obvious ML knowledge?
That's a good question.
I'll start. I'll be short. What you really need is back-end engineers. Hire back-end engineers, everything else will happen on its own. We're hiring.
So I'd say, data science is a very hot field. It's very, very hard to find good data scientists. If you look at profiles on LinkedIn, you'll see a person that's a data scientist now, was 3 years ago a statistician, and his title has switched. It's not easy to hire data scientists. So I would say what I would look at is, what have they achieved in the past? So in certain companies, the criteria is also domain knowledge. Example, if you're looking at data science with respect to voice, you ideally want someone that's done some work there or has a good understanding of the various frameworks within learning about voice. Within basically has some knowledge about natural language processing. So one, I'd say some domain knowledge. Two, someone that has proficiency around the domain, right? If you're in fraud, maybe someone that understands what are the key data elements that are critical for fraud. The other big part that I don't think comes out with data scientists is, I was very surprised when I was working with a lot of data scientists. Their main goal these days is simply getting relevant data and cleaning data. The model is a very, very small piece. And a good example is healthcare claims. Can you imagine getting clean healthcare claim data? That's a certain standard. Every doctor has a different way of writing. Doctor's handwriting, I hope there's no doctor. You're not exactly great, so trying to make sense of that. So just different parts.
I just want to say what he said. It's the infrastructure around productizing any AI requires so much effort that hire engineers, and people who can clean data.
Yeah, I think just kind of like wrapping this up, hopefully, is you need to figure out what you actually want. I mean, if you already have a great experimentation platform, Amazon, Facebook, Google, Microsoft, they already have these platforms, hiring a ton of data scientists that would make use of all the data that you store makes perfect sense. If you're just a startup that's growing, you want to productize everything, you want to productionalize everything. So it's great to have a data scientist on the team or a couple of data scientists, but at some point, you will want to roll out these things into production. If these are data scientists that are familiar with your system and can write production code, that's great, hire them. But if you don't want to be bottlenecked on either one. You don't want to be bottlenecked on being able to roll out things to production. You don't want to be bottlenecked on being able to generate insights. So make sure that you balance data scientists and different types of engineers.
Makes sense. And also, so tell me, my question along with that is, it's, we have models and model building is, we know that's important and there are so many help around it. But I think most important is the data cleaning, right? Data errors, understanding and going through the data and making sense of the data is also very important for the data scientists. That sometimes comes with the domain knowledge too. Sounds good. That's our last question, and thank you all for coming. So please give a big round of applause for